Okay, seventh grade, before you start these notes, please make sure that you have read over page 32 and page 33 in Investigation 2.3. There will also be times where I will ask you to pause this video so that you can do some of the work. And feel free to pause at any point in time if you need to catch up with taking the notes down, because I've already started my notes. So after you read 32 and 33, there's a few things that we're going to get down here. So number one is that all linear relationships can be written as equations using a form called slope-intercept form. We have been using this, I just haven't been calling it this. So the form is y equals mx plus b. If you remember, if you can think back to all the posters that were in our room, we definitely had one. I had one in the back for the 8th graders, and there was one that said y equals mx plus b on it. This is very similar to what we've been doing. So y is my dependent variable. Dependent variable is equal to some value. In our case, it's been the rate of change times the independent variable plus our starting point. So we're going to kind of give labels to all of these right now. So the y and the x. The y is my independent variable. The x, nope, I lied. Scratch that. The y is my dependent variable. Sorry about that. So x and y are variables, which means that these letters will stay there in this form. There could be all types of numbers that are attached to it. X is my independent variable. I'm just going to wait for that to dry. M is my what we call the slope. We have been talking about the change in y over the change in x. So this is the ratio. So here I could say ratio of change in y over change in x. So ratio of change in y over change in x. Why don't I highlight and color code this too, just so that we have it. So slope, m is my slope, which is all of this info. Y is my dependent variable, not independent, dependence. And my whiteout isn't dry yet. So that's my dependent variable. X is my independent variable. So y is dependent. X is independent. There, we'll just do that. So dependent variable, independent variable. And then my B, we've known it as our starting point, but B, that starting point is called the y-intercept. And you read about this in the book. The y-intercept is defined basically whenever x is 0, it's whatever that y value is. When x is 0, what is that y value? Let me grab a different color for that one. We'll use orange. So the B is the y-intercept. Okay, pause the video if you need to finish taking the notes. A coefficient is the number that multiplies a variable in an equation. In this case, the coefficient here is going to be m, right? So in y equals mx plus b, the coefficient is whatever is multiplying a variable. We know x is a variable and y is a variable. The number in front of the x is the coefficient. We again know that m to be the ratio, the change in y over the change in x. I have a couple of examples here. So If you think about Emile, so we have dealt with Emile's equation. The distance for Emile is equal to 2.5 t, and Henry's distance, so the distance for Henry is equal to t plus 45. We did those in our last investigation. Also, notice my notation here. I'm going to zoom in really quickly. This notation, d with the little Emile subscript and d with the little Henry subscript. All that does is tell me that this distance refers to Henry and this distance refers to Emile. It's like saying d equals 2.5 t. It just gives you a little more information about the specific d that we're dealing with. You're going to see that today in the work that you complete, because you're doing all equations today. No data tables or graphs, just equations. All right, so a coefficient here, our coefficient for this equation would be 2.5. And then our coefficient for Henry's equation is a little trickier. If you can kind of guess what it is, I'm going to put a little thought bubble here while you're taking a guess. So what do you think the coefficient of Henry's equation is? So t is like saying 1 times t. Anytime we multiply a variable by 1, it's simply the variable. So the coefficient is 1 in this situation. It's kind of like this little imaginary 1 sitting right there. I'll put a little 1 there. Okay. Solution of an equation is an ordered pair that makes the equation true and lies on the graph. The graph meaning the line. So it's a point that is actually on the line of that equation. So if we are given the equation d equals 45 plus t, so I'm using Henry's equation, we can say that the point 146 is a solution, 1 being the x value, 46 being the y value, or you can think of that as 1 being the time and 46 being the distance. So once I input those numbers, I have 1 and 46. If I input them into the equation, so this would be where 1 would go, and this would be where 46 would go. I'll do it down here. So there's the 1, and there's the 46. When I plug those in, when I work out both sides of the equation, 46 is equal to 45 plus 1, and then 46 equals 46. If it's a true equation, that means that you have a solution to that equation. All right, so you're going to try out a few of these. I am going to give you the equation. Y equals 5x plus 3. I want you to pause the video right now, and I want you to answer these 3 questions. Number 1 is 319, 3 being our x value, 19 being our y value, a solution to this equation. Use what you know, plug in what you know, see if it's a solution. Next, I want you to find out if when x is 17, what is y? Again, you're going to plug into the equation and solve. And then lastly, number 3, you're going to use your knowledge of river problems, so the river method that we've been using. If y is 186, what is x? So please pause your video and work out these problems. Okay, I hope you've come back to us. We're going to go through each one of these. So for number 1, I'm going to kind of zoom in here. For number 1, we can see when we plug 3 into the x value and 19 into the y value, I end up with 19 equals 5 times 3 plus 3. I just work out my expression on the right side of the equation, and I end up with 19 is not equal to 18. So 319 is not a solution to this equation. This point will not be on the line if we take this equation and we make a line out of it. For number 2, we'll go over here. Go over here. So again, pause the video if you need to. For number 2, when x equals 17, what is y? Well, 17 is over here. I'm looking for what y is. I plug 17 into x, and I end up with y equals 5 times 17 plus 3. I work out and I simplify the right side of my equation, and I end up with y equals 88. That y equals 88 gets plugged in to the coordinate pair. This point would be on the line of this graph that is y equals 5x. All right, the last one and the hardest one. Number 3. So when y equals 186, what is x? Right here, you are using your river method. So now I have a situation where there's a number sitting alone on one side, and I have to solve for x. So my first step, it's kind of like reverse order of operations. So I take care of any addition and subtraction first. 5x plus 3, if I subtract 3 from both sides, don't forget to make my river. That equal sign goes down the river. And then I'm left with 183 equals 5x. 186 minus 3 is 183. That equals 5x. 5 and x are connected by multiplication. If I want to undo the multiplication, I need to divide by that coefficient. So 5x divided by 5 reduces to 1. So I've got 1x on the right side, and then 183 divided by 5 will give me 36.6. That 36.6 gets plugged into the x, and then I already know that my y value was 186. So this point, 36.6, 186 is the solution, is a solution to this particular equation. All right, so today you guys are going to be working in Investigation 2.3. Letter A, number 1, 2, and 3. If you look at this here, Ms. Chang's class decides to give t-shirts to each person who participates in the walkathon. Whoops, went too far. They receive bids for the cost of the t-shirts from 2 different companies. Mighty Tea charges $49 plus $1 per t-shirt. No Shrink Tea charges $4.50 per t-shirt. Ms. Chang writes the following equations to represent the relationships relating costs to the number of t-shirts. So here's where we see those little subscripts. Don't get caught up by those. That just means the cost at Mighty Tea and the cost at No Shrink Tea. And then these are the expressions that represent their cost. Yeah, okay, so that's it. You have the information that you need. You are going to be answering number 1, number 2, and number 3. Remember, for each of these, you're going to have to utilize both equations. Number 1 is just asking you about these equations, what everything represents. 2 and 3, you're going to actually have to do some work and put some numbers into the equations and then solve for the other variable. If you have questions, you know where to find me. Good luck, and I will talk to you soon. Bye-bye.